Hello students, welcome you all in this next video where we are solving CBSE Science sample question paper for class 10 for the year 2025-26, and in this video I am going to start with 5 marks question of section C physics. Already I have uploaded section A biology and section B chemistry. If you are not still subscribed my channel, go through my channel and subscribe my channel so that you will get the notification of all uploaded videos. So let's start with the first question of 5 marks section C physics. So in 5 marks we are going to start with question number 39, and it has a or option, that is you can see here attempt either option A or B. So as I told, whichever question you will feel easy and whichever you can solve completely to get full marks, that you have to attempt. So here we will start with first A question. We will read the question. The arrangement of resistors shown in the above figure is connected to a battery. So here they have given one figure, and in this figure you can see the resistors. Here this is 25 ohm, this is again 25 ohm, and this is 100 ohm. So these are the three resistors which are connected to this battery. So this is the battery. The power dissipation in the 100 ohm resistor is 81 watt. So in case of this 100 ohm resistor, whatever power is dissipated, that is given, which is 81 watt. Now by using this all the information, we have to calculate question number 1, that is the current in the circuit. So we have to find out the current in this whole circuit. First you have to understand the question. Then the second one is the reading in the voltmeter V2. So we have to find out the reading in the voltmeter, that is V2, which is connected to the resistors 25 ohm and 25 ohm. Then we have to find out the reading in voltmeter V1, so which is here. So this V1 and V2 we have to find out the values. So let's start with the question number 1. And before substituting the values, first read the question properly and find out what all values you have. And then after writing given, then you can think which formula we can use. So now we are going to start with the first one. So I'll write it here, number 1. So we are going to find out this, the current in the circuit. So first write down what all given. So what we have the resistor, that is 100 ohm. So I'll write it here. We have a resistor, it is 100 ohm. So 100 ohm. Then they have given power, and the power is P, it is 81 watt. So I'll write 81 watt. And what we have to find out, we have to find out the current. So I'll write I is equals to question mark. Now according to this we have to use the formula. So I will use the formula of power, and that is nothing but I can write P is equals to I square R. This is the formula which we are going to use. But here in this sum you can see they have asked to find out I. So we will rearrange the formula, and after rearranging I can write it I square is equals to P divided by R. Now we can substitute the values. So I want to find out I. So I can write I is equals to square root of P divided by R. Now we will substitute. I is equals to, what is P we have? P we have 81 and R we have 100. So as we all know that 81, the square root is 9, and for 100 it is 10. So we can write it like this, 9 square divided by 10 square. So square, square, and this root get cancelled. And what will remain? The remaining will be I is equals to 9 divided by 10. 9 divided by 10 can be written as I is equals to 0.9 ampere. So remember we have to write the units. So current is measured in ampere. So I wrote here 0.9 ampere. So this is the answer for question. Now after this we are going to solve our question B, that is we have to find out the reading in voltmeter V2, and for third we have to find out the reading in voltmeter V1. So I'll write it here, number 2. Again I told first we have to write what all given. For given we have reading in voltmeter, that is voltage we have to find out. So I'll write V2 is equals to question mark. And the formula which we are going to use in this case, it is according to Ohm's law, that is V is equals to I into R, that is current into resistance. If you want to do this, we should know the value of current and resistance. Current just now we have found it out, that is I is equals to 0.9 ampere. But what about resistance? If you see this diagram, here V2 is connected to these both the resistors, and these both the resistors are connected to each other in parallel combination. So we have to first find out the effective resistance of these two. The effective resistance, or you can say equivalent resistance. To find out the equivalent resistance of these two connected in parallel, first we have to use the formula for parallel connection. So let me solve it on the other side. So to find out, so I'll write it, I'll put a dot, I'll write find effective effective resistance resistance of two 25 ohm resistors connected in parallel. So what is the formula for this? What we can use? We can use the formula, that is 1 by Rp is equals to 1 by R1 plus 1 divided by R2. This formula we can use. So R1, R2 both are 25, 25. So we can substitute the value. So therefore 1 divided by Rp is equals to 1 divided by 25 plus 1 divided by 25. No need to take the LCM because both the denominators are same. So I'll write it as it is 25, and this will be 1 plus 1. So 1 by Rp will be is equals to 2 divided by 25. This is the answer. Now reciprocal 1 by Rp, it is, we want only Rp. So Rp is equals to 25 divided by 2. Now divide this 25, we will get the answer. So what is the answer? Rp is equals to, so how to divide it? So divide it on the other side. So let me divide it here, 25 divided by 2. So what I can do? 2 ones are 2, 0, take 5, 2 twos are 4, 1, take 0, decimal, 2 5s are 10. So this is the answer. So what is the answer? Rp is equals to 12.5 ohm. So this is, we got equivalent resistance of these both. And the same thing we have to take it here. So I'll write it here. Rp is equals to, or just you can write R, 12.5 ohm. So we got the value. Now substitute the values in this formula to find out V2. So here I'll write it V2. So now start. V2 is equals to, what is the current? 0.9 into, and what is the resistance we have got? 12.5. So I'll write it 12.5. Now multiply these both, we will get the answer of V2. And the V2 answer is 11.25, because V2 means voltage, we should write the unit volt. And this is the answer for voltage reading or voltmeter reading, that is V2. Question number 2 is done. Now we are going to move with question number 3. Let me solve it on the other page. If you want to see this multiplication also, let me do it here, because I have a habit of doing all the calculations so that you will understand each and everything clearly. 9 5 is 45, so 4 here. 9 2 is 18, 18 plus 4, 19, 20, 21, 22. So I'll write it 2. 9 1s are 9, 9 plus 2, 10, 11. So plus, if you multiply with 0, you will get 0 only. So write it as it is. So 5, 2, 1 and 1. Now if you see the decimal where you have to take, you have to count the digit. This is 1, this is 2 and this is 3. So this is 1, 2 and this is 3. So therefore the answer is 11.25 volt. I hope you understood the calculation. Now we will move with the next one, that is third one, reading in the voltmeter V1. Now we have to calculate the reading in the voltmeter V1. So V1 is here. Now if you can calculate reading in this voltmeter, first we have to see what all resistors. So this is the first resistor which is connected, and then we have these two. And if you see, these two are in parallel. These two are in parallel, and the effective resistance or equivalent resistance of these two, that is nothing but just now we have calculated, it is 12.5. This 12.5, which is the equivalent resistor of these two, and this 100, this is in series. I hope you are understanding. these both are in series. So 25, 25, if you take separately, they are in parallel. And if you calculate the effective resistance of this 25, 25, which is nothing but 12.5, this 12.5 and this 100, these both are in series. So it is nothing but how the diagram looks, how the circuit looks. This is V1 and this is like this. So this is the battery which is connected and then comes like this. So here we have 100 which is given, and then once we calculate these both two, we will get 12.5, connect, and like this the circuit completes, and here it will be a V2. So it will look like this. So now we have to find out the reading in V1 with respect to these two resistors, and now these two are in series. I hope you understood now. So first find out the effective resistors of these two which are in series, and whatever answer you will get, this resistance we can use, and you can use the current which we have found out in the first question, and easily we can find out the answer of V1. So let's start. So first we will write given. In given what we have I value, that is 0.9 ampere. We have to find out V1. So V1 is equals to question mark. And then now as I told, we have to find out the effective resistors. And for this, I will write it here. Find equivalent resistor, equivalent resistance of resistors. I'll write it here of two resistors, that is, which are those two? 100 ohm and 12.5 ohm in series combination. So these are in series combination. So what is the formula for series combination? It is direct. So Rs is equals to R1 plus R2. This formula we can use. We know R1 and R2. So substitute the values. R1 we take 100 and R2 we will take 12.5. So what you're going to get here? The answer will be 112.5. Write down the unit ohm. So we got our effective resistance or equivalent resistance. So we got the answer of these two. Now we can easily substitute the values. So let me write it here. What we have again, Rs is equals to 112 point, sorry, it should be 112.5 ohm. Now take the formula. According to Ohm's law, what is the formula? V1 is equals to I, and this is Rs. Just now we have calculated. So substitute the values. So it will be V1 is equals to 0.9 into 112.5. Now we have to do the multiplication of this. Let me do the heat here. So see here 112.5 into 0.9. So first we will multiply by 9 here. So again 9 5s are 45. So 5, 4, 9 2s are 18, and this is 22. So 2 and 2. 9 1s are 9, 10, 11. So like this. Then 9 1s are 9, and this one will be 10. So I'll write it here 10. Plus, if you multiply with this 0 to all, you will get 0 only. So I'll write 0, 0 and 0. Now write down 5, 2, 1, 0 and 1. Now if you see the decimal point, as I told you, count it. 1, 2 and here 3. So 1, 2 and this is 3. So where should be the decimal? It should be after 101. Therefore V1 is equals to 101.25 and the unit is volt because it is voltage. So this will be the reading in question, that is, sorry, in voltmeter V1. So we have calculated first the current in the circuit, then we calculated the reading in the V2, and then we calculate reading in the V1. So I hope you understood the explanation of this question. This is the answer for this question number 39A. In this question we have an internal choice. After this we are going to start with question B. Now we are going to start the B question, that is the internal choice which we have. So or question number B we will read. An electric heater consists of three similar heating elements A, B, C. So this is the diagram which is given, and in this we have three similar heating elements, that is A, B and C. connected as shown in the figure. So you can see A and B is in series, and for these both, this C is in parallel. So I hope you're understanding. A and B both are in series, but for this both, this C is in parallel. So this is the connection. Each heating element is rated as 1.2 kilowatt. So each heating element is rated as this much. So power is given, and for all the heating element, power is equal, that is 1.2 kilowatt. Then 240 volt and has a constant resistance. So voltage is how much? Voltage is 240 volt. You can see here 240 volt and has constant resistance. So all the heating element has same resistance, constant resistance. Next, S1, S2, S3 are the respective switches. So here we have three different switches, S1, S2 and S3. So depending on the use, we can off or on the particular switches. So we have three switches here. The circuit is connected to 240 volt supply, and then by using this all the information, we have to answer these three questions. First question, calculate the resistance of one heating element. So any one heating element resistance we have to calculate. And remember, all the heating element, each heating element is rated as this much power, and this is the voltage and have the constant resistance. So now question number 1 is calculate the resistance of one heating element. Question number 2 is calculate the current in each resistor when only S1 and S3 are closed. Third question, calculate the power dissipated across A when S1, S2, S3 are closed. So one by one we will solve all the questions. So first we will solve the question number 1, that is calculate the resistance of one heating element. So here we have three heating element. So we have to find out the resistance of one heating element. So first we will write question number 1 which we are going to solve, and first as I will be telling, we have to write what all given. So given we have power is equals to 1.2 kilowatt. This we have to convert it into watt. We have to remove this kilo, and therefore for conversion what we are going to do, first remove this decimal. So when you remove this decimal to the right side, divided denominator will be multiplied with 10, so it becomes 12 divided by 10. This is still in kilowatt. Now to convert into just watt, it will be 12 divided by 10 multiplied by 1000. See, now it is in watt. So this 0 and 0 will be cancelled, and 12 into 100, so it will be 1200 watt. So now we got the P value. P is equals to 1200 watt. Now again what we have? We have a voltage, and voltage is how much? Voltage is 240 volt. So now we have P and V value. We are going to calculate resistance, and for that we have to see the relation between P, V and R. And the relation is P is equals to V square divided by R. This we can use. Now in this formula we have to calculate R. Therefore rearrange the formula. We will get R is equals to V square divided by P. So now this we can use to find out the R value, because we have V value and we have P value. Therefore, what I'll do it here. So I'll take R is equals to, what is the value of V? 240. So I'll take 240 square divided by what is P? 1200. Now solve it. So first 240 into 240. See here. Solve it step by step. 1, 2, 0 and 0. So 0, 0 cancel. So let me change the color. 0, 0 cancel. This 0 and this 0 cancel. Now see, 12 ones are 12 and 12 twos are 24. So now what is remaining? The remaining is, I'll solve it here. R is equals to 2 into 12. This is the remaining. So R is equals to 48 ohm. So we got the resistance in one heating element. So this is the answer for question 1. After this, we are going to start with question 2. So, and this question 2 we will solve on the next page, because it is a little bit of big procedure. So now we will solve the question 2. Calculate the current in each resistor when only S1 and S3 are closed. Now see in this circuit diagram, if S1 is closed like this and if S3 is closed, then what happens? Here this A and B both are in series, and this A and B with C, they are in parallel. So see, whatever current is traveling from this battery, it will divide equally in this A and B and in this C. And then this all the current from this switch, from this, it will come straight, and from here it will move like this, and then it joins and moves straight, and the circuit completes. So according to this, now we have to find out the current in each resistor. And to find out this, what you have to do, as I told now, S1 and S2, if they are closed, then A and B both are in series. And with respect to C, they are both are in parallel. So this all, first we will write it, and then we will start solving the current. So I wrote here, when S1 and S2 are closed, then heating element A and B, these both are in series, and they are in parallel with heating element C. Therefore, the potential difference across A and B is equal to the potential difference across C. Therefore, now we can write what all given. So given, we have potential difference which is same, that is 240 volt, I'll write it, and the resistance is same in all. So what I can write? RA, resistance in A heating element, RB, resistance in B heating element, and resistance in C heating element, it is equal, and we have find it out, it is 48 ohm. So I wrote this all. Now we have to find out the current, but to find out the current we have to use the formula V is equals to IR. And to use this formula, here first we should know the resistance. So resistance first, for these two which are in series, we have to find out the equivalent resistance, because whatever current is flowing in A, the same current will flow in B, because these both are connected in series. So that's why first we have to find out the equivalent resistance of these series combination, and then we can use to find out the current in these two. And after that we can find out the current in C element. And for this what we will do, I'll write it. Number one, equivalent resistance, equivalent resistance across A and B heating element. So I'll write heating element. And how these both are connected? They are connected in series. So we know the formula of series connection. So what I can take? Rs is equals to Ra plus Rb. Now what is Ra, Rb? Already we have wrote. Substitute the values. Rs is equals to 48 plus 48. So Rs I can write, or we can say Rab, equivalent resistance across A and B, will be how much? 96 ohm. So we got here resistance. Now we can easily use the formula, that is Ohm's formula. So first we will find out the current in IC. IC means current in C heating element. So I will write it here. Therefore, first current in C heating element. So this can be denoted by IC. So that's why I'll write it here, I and C. So write down what all given again. So given we have V is 240, which is already there in the question, and RC means resistance of C, it is 48. So you can see for all it is 48, so RC it is 48. So use the formula to find out V is equals to IR. So as I told, we have to find out the current. So if we rearrange the formula, we will get IC is equals to, this will be I into, wait a minute, V divided by R. R is nothing but, you can take RC also. So now substitute the values. IC is equals to, what is V? How much V we have? 240. So I'll write it 240. RC, how much we have? It is 48. So I'll write it 48. Now divide this. What we will get the answer? I will divide it by 2. 2, let me change the color. 2 2s are 4, 2 4s are 8. 2 1s are 2, 2 2s are 4, 2 zeros are 0. Still we can divide. So here what I will do? 2 1s are 2, 2 2s are 4. Then 2 6 are 12, 2 zeros are 0. Now see, 12 ones are 12, then 12 table, 12 fives are 60. So 12 fives are 60. So what is the answer we are getting? We can write IC is equals to 5 ampere. So we can write like this. So current in heating element C, it is 5 ampere. So that's why I have written here C. I means current, C means it is indicating the heating element. So we got current in one heating element, that is C. Now still A and B is remaining. Now A and B both are connected in series. So whatever current will move in A, same current will move in B. Therefore now we will find out the current in A. So here now I'll write current in A and B heating element. And how we can denote this? Because we are finding the current in both, we can denote it as I A B. So like this we can denote. So what we have, first we will write given, as I had told that already. Whenever we will solve numerical, first we should write what all given. So V is equals to 240 volt. So I'll write 240. Then we have resistance and resistance symbol. What we can write? RAB we will write, because both are in series. Or you can write RS also. So RAB or RS is equals to how much we have got? Just now here we have find it out. It is 96 ohm. So our formula, Ohm's law, that is V is equals to IR, or I can write it as like this also we can write, which will be very easy. So that is nothing but V is equals to IAB, and sorry, R it should be RAB. Now we have to find out current, no? So rearrange it. So IAB is equals to V divided by RAB. Now substitute the values. What we have, IAB is equals to, but we can write it for this, that is V divided by 96. Now we will divide it. So now I'll use first 2. Here 2 4s are 8, 2 8s are 16, 2 1s are 2, 2 2s are 4, 2 zeros are 0. So what we got it here? We got 120 divided by 48. This still we can divide it by 2 table. 2 2s are 4, 2 4s are 8, 2 6s are 12, 2 zeros are 0. So here we got 60 divided by 24. Still we can divide it. I will use 12 table. So 12 2s are 24, 12 5s are 60. And here what we got? We got 5 divided by 2. Still we can. So now this again we can divide. 2 1s are 2, 2 2s are 4, 2 5s are 10. And this is the last one. So here we can write current flowing in A and B resistance will be 2.5 ampere. So this is the answer for this question, that is second question. They have asked to find out the current in each resistor. So in heating element IC it is 5 ampere, in A and B it is 2.5 ampere. Now after this we will move with the third question, which is asked in the same question, that is on the next page. So now the third question, that is calculate the power dissipated across A when S1, S2, S3 are closed. Now see this diagram, we have to find out the power dissipated in A heating element when S1, S2, S3 all three switches are off. So imagine this is also off, this is also off, and this is also off. Now what happens? Whatever current is coming from the battery, now see, whatever current is coming from the battery, it will travel like this, and once it comes here, this power will divide equally in C heating element and in A heating element. I hope you are understanding, because A and B both are in series and these both are in parallel to this C heating element. Therefore, whatever current is coming from the battery, it is equally dividing into A and B and C. The current which is coming in the A will travel from the A, and instead of going in B, it will travel through this wire and travel from this switch S2. Why it will travel from S2? Because B has resistance, and that resistance will avoid the flow of the current. And because it has a resistance, as I'm telling, it will prevent the flow of the current. But in this wire, easily the current can move because the switch is off. So instead of moving in B, where it is going to avoid the flow, it will try to move towards this wire. It will go from this S2 and comes here. And the current which is coming from the C heating element, it crosses C. Because S3's switch is off, it will travel from the S3 and it comes and joins here. So this is the flow of current, and from here again it will move and the circuit will get complete. So like this, the current will pass into this circuit diagram when S1, S2 and S3 all are closed. By using this information, we have to find out the power dissipated across a heating element. So whatever I told just now, that I will write it here whole. So I have written here, when S1, S2, S3 are closed, then current will pass only through A, only from A, and no current will pass from B because the current is going to move down towards the S2 switch. Here heating element A and B both are in series in combination and also have the same resistance. Therefore, same current will flow from both. So now we will write what all given. So therefore, given what we have here, we have current, that is IA, which is 5 ampere. Then we have RA, resistance, that is 48. Because for only one heating element we have to calculate and the resistance is 48. And power we have to find out. So the formula which we are going to use it for this, power in A is equals to I square R. So we know the values of I and R, substitute the values and find out. So PA is equals to, power in A is equals to, what is I? 5. So 5 into 5 into 48. So this becomes 25 into 48. And this if you multiply, you will get the answer 48 into 25. So 5 8 is how much? 40. 5 4 is 20. 20 plus 4 is 24. Plus, then what we are going to get? 2 8 is 16. 1. 2 4 is 8 and 1 9. So 0 0 1 10 12. So this is the answer. So PA is equals to 1200. So this is the answer. Therefore, the power dissipated across A is. So I'll write 1200. And what is the unit of power? It is watt. So I'll write it watt. So like this, we have completed the answer of all the question 1, question 2 and question 3. So here we have completed the answer for 5 marks question from section C physics. And with this, I have completed the sample question paper for CBSE syllabus for the year 2025-26. And if you have not still subscribed my videos, please subscribe my channel so that you will get the notification of all the uploaded video. These all the videos or the answers will help you to solve or to prepare for your final exams. So like my videos and share my videos with your friends. Thank you so much.